Welcome, everyone. My name is Katrin Weller. I'm deputy head of the Computational Social Science Department at the moment, and I will today give you a short introduction on computational social science and digital behavioral data. And the overall idea of my talk is really to give you an idea on what computational social science means. We will have follow-up topics, 2 more talks in the next 2 weeks, and then a bigger series coming up from September to December on more in-depth topics related to computational social science and digital behavioral data. So today is the getting to know the topic talk, and then more details will follow later on. You might have come across the term computational social science without knowing exactly what it means. You might have also come across all these various other buzzwords that are currently appearing in different contexts, like big data, data mining, digital traces, mobile sensors, all these kind of things, which are sort of related to computational social science and play a role in the field of computational social science. And I hope to be able to contribute a bit to you getting some clarity on how all this fits together in the end, at the end of this talk. But what actually is computational social science? And most importantly, what can it do for you as a potential social scientist listening to this talk today? We will take a first look at some illustrative examples of what computational social science means and what it can do for you. So sometimes you might want to ask study participants questions that they might find a bit difficult to answer. So for example, asking them, how often do you talk to your friends on the phone? How many hours do you spend outside your home? Or you attended a conference last week and now you are asked, to how many people in total did you talk during that conference? And yeah, for the person who is to respond, this might not always be easy to recall. And in fact, sometimes there are digital devices or digital sensors that may be better in recalling certain facts than the human memory itself. Let's start with the example. You attended a conference, an academic conference, and now someone wants to know how many people you've been talking to. My colleagues at the CSS department and also as the SDM department at GESIS have been running experimental setups with RFID sensors. So these are little tiny badges that you attach to your shirt, for example, and that record face-to-face interactions. So when 2 people wearing a sensor stand close enough together for a longer period of time, this will be recorded by this specific sociopatterns sensor technology. And this can then be used to create networks of connections, who has been talking to whom, and even for what period of time. So at the right side, you see this network. If you collect, for example, by an additional survey, information about demographics, for example, at this conference scenario, what disciplines people work in or their academic age, you might be able to create meaningful networks of who has been talking to whom. And you can also map that to the timeline of the conference, as you see below, and you will find certain spikes in which people have been close to each other and talking to each other, which in the conference scenario, not surprisingly, relates to the coffee and lunch breaks. But this can also then be linked to, as I said, additional survey data, for example, also about previous connections, and you can look for details on number of contacts, the time people have been present during the conference, and so on and so forth. So that would be an experimental setup where you would explicitly ask people to join in this setting, wear their sensor, and be part of that study. In many other cases, sensors are already built into everyday technology that people are using anyway, and are thus producing digital behavioral data sort of as a side product. So without a researcher stepping in and saying, I now attach this sensor to you. So one example for this scenario would be the mobility monitor that is part of the COVID-19 mobility project. So in this case, data comes from mobile phones and is provided by the mobile phone companies, and it gives you data on where the phone has been in a certain period of time, assuming that the phone doesn't travel on its own, but is on a journey together with a human person. And this data can be used to see in which German regions, so you have this map perspective, in which German regions mobility was lower or higher during certain periods of time. And if you relate that to the pandemic and the upper right graph, you will see that mobility has dropped significantly in March 2020 due to the lockdown measures in place. So in that case, the sensor is the mobile phone that the people have anyway, and the data is being collected by the phone companies. There are many other digital devices or digital platforms that on the side collect certain types of digital behavioral data. So that's what we call this type of data. Digital behavioral data is the term that summarizes a variety of potential data sources that potentially also record different types of activities, from taxi rides or car sharing or bike sharing rides to credit card data use, gaming, details from digital gaming, digital cameras, of course, phone calls, geolocation data built in different devices, and of course, lots and lots of data related to how you use online environments, online platforms on your computer, on your smartphone, on your smartwatch, maybe also. And this includes lots of social media content, for example, but also lots of other common activities in a variety of digital platforms, since they increasingly shape our everyday life in so many ways, from shopping to online dating to keeping in touch with family and friends. All these things are happening in online platforms and potentially create digital behavioral data within these platforms alongside. With these digital behavioral data, can help us to identify what we call the ABC at the moment, the attitudes or opinions, behavior, or other types of characteristics of human users of the digital technologies. So that's why these digital behavioral data are of interest to computational social scientists of different backgrounds. Another example, imagine I am asking you today, as of today, in a survey, okay, what did you think about the preventive measures during the first wave of the COVID-19 pandemic? So more than a year ago. And most likely you might have an opinion on the measures right now, but it's quite hard to tell if that is exactly the recollection of how you felt back then in March or April 2020, when the actual first wave kicked in and the measures were imposed. And that is a not uncommon problem in creating survey-based research, that often the period from getting the survey out into the field and the potential events it might relate to cannot be kept very short in many cases due to the necessary preparations. But there are options for mining opinions from existing digital communication streams, for example, that can be more timely in these contexts. So especially in the case of unforeseeable events like a pandemic, but also like a natural disaster, social unrest and protest movements, these kind of things, there are people immediately reacting to this in different social media environments, in online communication channels. And these data might give a very short notice idea of what people feel about the events as they unfold. So in this COVID-19 scenario, for example, you still can find tweets from March 2020, so from a year ago, like the one on the right-hand side of someone issuing a concern why so many people suddenly seem to be surprised that they are supposed to wash their hands during this pandemic. So this would be an example of a immediate reaction on Twitter back then. And this includes also cases like on the left side from public figures or people of a more general public interest, like in this case Elon Musk, who back in March 2020 wasn't really believing in the coronavirus as a serious thing. So his tweet reads, "The coronavirus panic is dumb." And we have another person reacting to that in August, so a few months later, if that's questioning if that's still the opinion here. In other cases, digital behavioral data may also enable looking into topics for which it would be really difficult to recruit study participants otherwise. And another benefit is that they are often, in many cases, created without any stimulus from the researcher. So there's no one saying, please go to Twitter now and tweet about the pandemic. But this is data that is happening anyway. Let me give you another example. So let's assume we are interested in personal well-being and have to come up with ways on asking people how they feel, how they felt in the past month, how their well-being has changed over time. And this may lead to useful answers, or it may not. You have to work with what the person answers, of course. But imagine there would be different options to enrich survey data in those cases with digital behavioral data. For example, body functions being measured from smartwatches or other devices that measure for sleep duration, for example, heart rate and other components. So these are already being used in some context as via data donations, for example, to measure body functions that in some cases also relate to health factors or can also be related to subjective well-being. So the paper listed here looks at different options for measuring subjective well-being with additional digital trace data, digital behavior data, also minutes, active minutes using a smartphone or another digital device, how the writing style of a person might change in different situations of well-being or episodes of different physical health states, for example. So these are data that can be collected. Of course, there need to be ways to obtain consent from the people in these cases, and that leads to additional challenges, which we talk about in another specialized talk later on this year. But there are possibilities, and there are possibilities being explored to use this kind of data to measure or to complement data about well-being. Another option would be photo content. So what kind of photos are people taking of themselves? How do they look like? How do they share and present that? And that's, yeah, all adds up to complementing the picture of how well or not well someone is feeling. There are other cases, especially in the area of health-related information, mental health, and other very intimate data, where it might make sense to study specific online communities. Also because from a computational social science perspective, it is very interesting to see what practices of talking about specific psychological feelings about intimate data emerge in online environments, in protected spaces online. And the paper I'm listing here is an example of someone doing, yeah, some sort of computational social science version of ethnographic research in an online platform. So they are studying users of the platform Reddit. So that's also a communication platform where people discuss in a forum-like style different topics and center around different topics. And one of the topics there is called Data is Beautiful. So there's a subreddit called Data is Beautiful, in which people who meet in this online space share live logging data, so data they have tracked about themselves, sometimes in nice visualization formats, and the authors call that confessional data selfies. So data presentations shared by the Reddit users about aspects of their life, such as sleep patterns, how they used online dating for a while. There's also a case of someone tracking the sleep patterns of their kids, for example. Someone recording every minute of their day in an audio file and sharing that with the community. And of course, this is interesting on the dimension of so what's happening in the lives of these people, but it's also interesting to see how these people make use of these platforms to actually share insights about very intimate moments, such as grief or sickness and other experiences that they might not talk about very openly in other contexts. Okay, now we've seen quite a few examples of what digital behavioral data might look like and why it might be interesting to go into that more deeper. But I think I haven't really answered your question on what is computational social science yet. So let me try to do that now. Computational social science is a research field that makes use of a different set of computational models, therefore the computational in the name, to collect, on the one hand side, collect and to analyze data, and especially large-scale data and the type of digital behavioral data that I've shown you in the examples, in order to study socially relevant phenomena. So there's the social part in there. So we need specific set of methods in order to get new kinds of data or large sets of data that are hard to handle without computational support, and use that to explore new phenomena or old phenomena in new contexts that have some social relevance in the end. Slightly different phrased by one of the key figures in the field of computational social science. So David Lazar and his colleague have used this definition. We define computational social science as the development and application of computational methods to complex, typically large-scale human, sometimes simulated behavioral data. So similar description, slightly different phrased. And this is taken from one of the key publications in the field, which is the lower one in this screenshot here. But it's the follow-up publication of one of the initial papers catching broad attention that defined computational social science. So this was happening in 2009 when a group of researchers from different backgrounds and led by David Lazar in this case wrote a science article on defining computational social science. And so this was in 2009. There is a updated version, so to say, from 2020, so a bit more than 10 years later, which nicely shows that computational social science is an evolving field. So the authors are reflecting on which new challenges have emerged, like a more specific focus on research ethics, for example, and on data sharing practices, and also report on how the field has come together from different perspectives. And I'll show you this as a reminder that this is a relatively new field of research. It is still evolving. There are many challenges still being addressed, still being discovered and updated, and a lot of things are still happening, which means that for many scenarios, there's also not a one-fits-all solution yet, but the need to go into more details, figure out what is the right solution for a specific case. Yeah, it is evolving. It is a lot is happening in this area, and so far we've talked a lot about the data perspective, what kind of data might be useful. The other aspect that is happening at the moment is that computational methods are being explored and developed in many different forms, and these computational methods are a way, as I said earlier, to collect the data that you might want for a specific project, but there might also be new methods to analyze large data sets at scale, and this can also help to discover really longitudinal data, multi-country data from different contexts. So these are other aspects that make these approaches interesting. In many cases, computational social scientists draw from methods of machine learning. So machine learning methods are of particular interest to CSS researchers because they enable, based on existing training data, to train an algorithm so that the algorithm learns in the way an algorithm can learn, to interpret and sort data into categories, for example. And this can then help to detect meaning in large data sets. So the algorithm is looking for patterns, for similar features of a large data set, and will sort that according to a self-learning approach. Yeah, one example that is heavily drawing on machine learning, in this case on visual data, is a project on predicting poverty. So the motivation here is that for for many countries that are affected by poverty, it is hard to get updated survey data on the actual status in that country. So I think the example in this paper is Angola, but there might be other countries similarly affected where you are not able to run a survey not even every 10 years to measure the state of poverty there. And the authors of this paper have explored options to use satellite images that are available and train models that detect features in these satellite images, and they distinguish nighttime and daytime pictures. For example, looking for sources of light in the day and other characteristics like roads and buildings. Or did I say lights in the day? Of course, lights in the night, and roads and buildings during the daytime that can then, by the extent of these features being available, give a hint on how well or poor these areas might be. And that is one way where machine learning models can help to explore this available satellite data for the purpose of studying poverty. Of course, and I think that's the key direction in which the more social sciencey community of the broader social science community is going to. Digital behavioral data can also be combined with other data sources, especially with survey data. And they should be combined in many cases in order to get the best possible results and the best possible insights. I'll give you another example from my colleagues at different GESIS departments. So this is an example of combining traditional survey data and data from a web tracking tool. So web tracking means that people consent to install a little browser plugin, so a feature in their computer or mobile phone browser that will track their online behavior meaning it tracks which websites you go to, how long you stay on them, and how often you access these websites, for example. This data is captured and stored based on also informed consent. And in addition, the participants who have agreed to take part in this study can also fill in surveys asking, for example, about opinion on political topics, recent events, and other scenarios. And in the case of my colleagues, they were particularly interested in whether people would access news websites. So the first step here would be to, from all the websites that someone is going to, only identify those that relate to news content, and then find out how long people have visited these news pages, what contents they might have seen there, and then try to relate that to their political or other opinion on, ideally, these very topics that they have seen. Computational models can be developed, can also be developed or can be used to test existing social science concepts with new types of data, with other types of data. And so this is another area where we see convergence of computational methods and traditional social science knowledge. So one example for this would be the paper on predicting tie strengths. So the concept of social ties is derived from social science theories. So we're interested in different types of interpersonal connections, from loose acquaintances to very close friends. And the authors of this paper tried to apply this theoretical concept of tie strengths to Facebook data. So assuming that people connected on Facebook are also representing different types of tie strengths. And what they did is they combined, again, survey data and digital trace data. So in that case, they would do it in an experimental setup. So people would be shown there, or would, together with the researcher, open their Facebook profile and would have to label for their different Facebook friends how strong they feel connected to this person, or what the nature of the connection to this person is. While at the same time, the researchers would get additional digital behavioral data from the person's online activities, like commenting on Facebook posts, for example, of the respective persons. And then this gives a way to connect what the participant has said about the connection and what the data shows about what is happening in the actual online environment related to this data. So a nice example of also combining different sort of methods and for bringing together ideas from social science theory that can now be applied in different contexts and enriched with additional data. Sorry. Prediction approaches are existing in very many contexts in computational social science. So a quite large subportion of computational social science and computational methods is dealing with finding approaches to predict certain things based on digital behavioral data. And this is happening with varying success. So two examples that caused quite some attention in the research community are a paper trying to predict election outcomes. So I think this was the German election 2009 probably. And the authors wanted to predict the election outcome. Well, they applied the prediction model after the election, but they kind of simulated what would have been predicted here. And the other case is an approach to detect influenza epidemic phases by using Google search query data. So based on how many people, for example, search for flu or for flu-like symptoms in an online search engine, can we detect whether there's a wave of influenza cases happening at the moment that might be more accurate than official health records available. And both papers were quite well received, but both papers also were responded to by different research groups later on that showed that maybe the predictions were not that good as claimed in the beginning. So in the election prediction case, there's a paper showing that actually if the data collection period had been slightly shifted, then the same prediction model would have predicted the Pirate Party to win the 2009 election, which as far as I remember did not happen in 2009. And in the other case, the Google flu prediction algorithm at some point didn't produce good results anymore. And the researchers behind it were a bit surprised on why that happened. And apparently, the authors of this reflection then dig into the details that apparently there was no one really controlling why it worked in the first place. And so the question was, what happened in human behavior that led the model to no longer predict accurately the number of flu cases into the future. So this as a first warning that there's a lot to consider when trying to predict from digital behavioral data. Okay, so have I answered what is computational social science yet, and what can it do for you? I think I've partly answered this two-level questions. So we've seen a definition for computational social science, and I'd like to summarize now at the end what it can do to you, can do for you as a social scientist. So it can help you to study genuine digital phenomena like people sharing intimate details in specific online spaces. It can help to collect new types of data and to pre-process them to make them usable in usable formats. And it can help by developing new types of methods to also analyze large-scale data sets of different sorts. So that's the approach of computational social science. And it should be viewed as a new sub-area for social science research, or as a new toolbox to complement traditional social science approaches that might be suitable for some cases and less suitable for others, for example. Yeah, and to clarify a bit, so you remember we've had all these different terms floating around here that you may or may not have heard in the past, and to sort them a bit into how they relate to computational social science, and therefore to wrap up my introductory talk, I'm using this graphic here. So we've got computational social science on the lower level as an area using new data sources, and we've seen quite a few examples for that. So sometimes they are referred to as big data, but it's more of a buzz term that you don't have to worry about so much. I think more important is thinking of it as digital behavioral data or digital trace data, and that can come from a variety of sources like social media, mobile sensors, smartphones, other smart devices, and many, many more. So this is by far not inclusive of everything. I've left out a whole lot here, but it's, I think, to give you a general idea of what we're talking about. And in order to get these new types of data, we need new types of data collection methods, and that might be approaches of mining data from different online platforms, of scraping text from web platforms, of applying additional tools that track activities, like the web tracking example that I gave. So all of this and many, many, many more that were not in this talk make up the new data collection methods. And then finally, in the upper part of the figure, you see the buzzwords, so to say, for which kind of methods are being applied. Again, there's much more also happening here, but just to give you a few of the very popular ones being applied, we've got sentiment analysis for as an example of natural language processing to deduce meaning from written text. We've talked a bit about machine learning approach that help to sort through big data sets, but there's also network analysis approaches in many areas. And often all of this is somehow labeled under the umbrella term of data science that you might have come across also. Yeah, and as I said, I can't go into all these details today. And I also cannot go into all the question marks that may already have arisen while you were listening to this talk, and that of course affect all these things to different degrees, and that is questions about data quality. So of course, if you use data that has not been created for research purposes, there's always a question of how good is the data and how valid is whatever we will do with it. Questions about how to evaluate new methods, for example, questions about what's the best strategy to collect data sets for these kind of purposes. Lots and lots of ethical questions that some of you might have already imagined while I showed the example cases, or as a kind of sister term, legal constraints in accessing the different kinds of data from these platforms. And we're hoping to give much more details on all these dimensions in the future. If you're interested to join us again in the upcoming talks. So as I said, we've got a mini series right now, and that is one more talk next week by my colleagues Fabian Flöck and Indira Sen, and they will talk about the more critical perspectives on working with this kind of digital behavioral data collected from online platforms. So they talk about potential research designs and also the error sources that may occur along the way when working with this kind of data. Next week, Thursday. And the following week, we have a talk specifically focusing on the chances and challenges of combining survey data and digital behavioral data by my colleagues Sebastian Stier and Johannes Breuer. And yeah, these two talks will be the kind of first snapshots into computational social science, and then there will be a bigger series with more diverse set of topics coming up starting in September and probably until the end of the year. So watch out for this. And apart from that, we're also happy to answer questions on computational social science and digital behavior data. We sort of training courses as part of the GESIS training program. So check out all these information from the GESIS website. But for now, let me thank you for being part of this, and I'm looking forward to the questions you may have today.